Okay, today we're going to talk about lesson 10.5, and 10.5 is going to discuss what happens when you change the dimensions of your figure. What happens to the perimeter and what happens to the area. So we're first going to take a look at example A, and we're going to focus on the perimeter of our figures. Now I want you to know in this first triangle that I have a right triangle. I'm missing one of my sides, but I could use the Pythagorean theorem, a squared plus b squared equals c squared, to find that that missing side would have to be 5 centimeters. Okay, now the directions ask us to describe the effect of change on the perimeter when the base and height of the triangle are multiplied by 3. So what I want to do is I want to think about, okay, if we multiply the base and the height of our triangle by 3, it's going to make it much larger. And although my drawing's not really to scale, I like to have a visual. So I know 5 times 3, this would be 15 centimeters. 12 times 3, this would be 36 centimeters. And 13 times 3, this would be 39 centimeters. Now, if we take a look and we think about the perimeter for my original triangle, I would just add up the sides. 5 plus 12 plus 13, and we'd find that the perimeter was 30 centimeters. If I take a look at the perimeter for the new triangle, and I add up the sides, well, I would find that that perimeter, 15 plus 36 plus 39, gives me a perimeter of 90 centimeters. Now, the question is, describe the effect of change. So what happens from my old perimeter to my new perimeter? Well, we can easily see that from 30 to 90, the perimeter also multiplied by 3. So that's actually the answer. I'm going to say P for perimeter. The perimeter multiplies by 3. Okay, let's take a look at a rectangle. It says the base and height of your rectangle is multiplied by half. Okay, well my rectangle 4 by 7, I know that sides are the same, top and bottom are the same. If they were to multiply the base and height by half, it would get smaller, right? Multiplying by half means divided by 2. Well, 4 times half is 2. 7 times half is 3.5. What about if we take a look at the perimeters? So for my original rectangle, 4 plus 7 plus 4 plus 7, I find the perimeter was 22 feet. For my new rectangle, when I add 2 plus 3.5 plus 2 plus 3.5, I find the perimeter was 11 feet. How can we describe the effect of change? Well, when I go from 22 to 11, I can see, oh, well, that also multiplies by half, right? So my answer, I can say perimeter multiplies by 1/2. Now, some kids might look at this and they say, well, the perimeter divided by 2. And that is correct as well. So multiplying by half and dividing by 2 means the same thing. In the textbook, they're always going to talk about what factor it's multiplied by. And so that's how I'll write my answer, but I would accept divided by 2. Now, in example B, they want me to look at the area. We're still going to use our triangles and our rectangles, but now we're going to think area. And I know that when I look at the area of a rectangle, we would take 1/2 base times height. Well, in my first triangle, I would have a base of 12 and a height of 5. 1/2 base times height, or half of 60, and we would find that would be an area of 30 square centimeters. The new area, when we take 1/2 base times height, well, we have a base of 36 and a height of 15. If you go ahead and multiply that, you're going to find that that's an area of 270 square centimeters. Now, does that multiply by 3? No. If we were to take 270 divided by 30, we would find out it goes into there 9 times. So the area is actually 9 times bigger, or multiplies by 9. What about if we look at the area of the rectangles? The original rectangle was a 4 by 7. Well, base times height, we'd find an area of 28. My new rectangle, base times height, we'd have 2 by 3.5. 2 times 3.5, we get 7. Does it multiply by half? No, it's actually going to multiply by 1/4, right? I could find that if I take 7, my new one, divided by my original, I get 0.25, and I know that's 1/4. So here, my area multiplies by 1/4. Well, we're supposed to start to see a pattern or to notice something. And as we look at the top, when we looked at our perimeter, if the base and height multiplied by 3, the perimeter multiplied by 3. Or if the base and height multiplied by half, the perimeter multiplied by half. So the perimeter always changed by that same factor. When we look at the areas, well, when the base and height multiplied by 3, the area multiplied by 9. That's actually 3 squared. When my base and height multiplied by half, my area multiplied by 1/4, well, that's actually 1/2 squared. And that's actually always going to hold true. The perimeter will change by the same factor, whereas the area is going to change by that factor squared. And we had kind of talked about that in Chapter 7. Now, we could take a look at our circle, and we could do our calculations for circumference and area. What I want you to notice is that when I calculated for my circle, I left my answers in terms of pi, because it's a lot easier to work with that exact answer. Now, my original has a radius of 10, so the circumference would be 20 pi, and the area would be 100 pi. If I look at taking my radius and multiplying it by 1/5, that's going to become a lot smaller, right? 10 times 1/5 is actually going to give me a radius of 2. Well, if I think about that circumference, pi times d, I would actually get a circumference of 4 pi. 4 pi centimeters. If I think about my area, pi r squared, well, I also get 4 pi. But this is in centimeters squared, so the answer is actually different. One's a linear unit and one's a square unit. Now, when I compare, what happens to my circumference? If I go from 20 pi to 4 pi, well, when you divide those, 4 pi by 20 pi, you would see that this is actually multiplied by 1/5. So the circumference multiplies by that same factor, because the circumference is like the perimeter. The area, does the area multiply by 1/5? No, to go from 100 pi to 4 pi, well, when we divide it, 4 pi by 100 pi, you get 1/25. The area multiplies by 1/25. Why is it 1/25? Well, if you take 1/5 squared, that's what you get. Okay, so on the back side of the notes, there's this summary chart at the top. And sometimes you're able to use that chart to know what's going to happen without having to do all the calculations. Now, when you change your dimensions proportionally, your dimensions, if they change by a factor of A, your perimeter or circumference will also change by that factor of A. But your area is going to change by the factor A squared. So for example, if we know that my dimensions were times by 2, my perimeter would also times by 2. But my area would actually times by 2 squared or times by 4. Okay, let's take a look at a couple more examples. In question number 1, it says a square has a side length of 5 centimeters. If the area is multiplied by 9, what happens to the side length? Now, what I would suggest is if these questions are a little bit difficult for you, I would sketch yourself a picture. So we have a square. That's not very good. And the side length is 5. Now, mine aren't going to be drawn to scale. It says if the area is multiplied by 9, what happens to the side length? Okay, well, I know that this initial area is 25. 5 times 5. Now, here, my area is going to multiply by 9, and it's going to be a lot bigger. If I take 25 times 9, I find out I get a new area of 225. So this square has an area of 225. The question is, what happens to the side length? Well, the first question is, if we wanted the side length, what is it? Something times something is 225. If I wasn't sure, I'd take the square root of that, and I'd find out that this is actually a side length of 15 by 15. What happens? Well, when I go from 5 to 15, I see that my side length actually multiplies by 3. Right? So that is my answer. Actually, I'm going to say the side length multiplies by 3. Now, I could have kind of taken a shortcut on that. If the area multiplies by 9, that actually is the a squared factor. A squared is 9. The side length, well, if the side length is my dimension. So if a squared is 9, a would have to be 3. And that would tell me how the side length is going to change. So sometimes if you already know what's going to happen, you may not have to do all of this figuring. All right, let's try another one. In question number 2, it says that a rectangle has a base of 10 and an area of 40. Well, let's sketch that. My rectangle has a base of 10 and an area of 40. So you know what? If my area is 40, I know that this is going to be a 4 by 10. Okay. Now it tells me that the area is quadrupled. So if the area is quadrupled and I have a new base of 20, it's going to be a lot bigger. And again, mine may not be drawn to scale, but quadrupled means times by 4. 40 times 4 is 160. Well, if this is 20, area of 160, I would have to have a width of 8. The question is, what happens to the perimeter? Now, I could find each perimeter adding up my sides, 10 plus 4 plus 10 plus 4, 20 plus 8 plus 20 plus 8, and I could compare. But the other thing that I could note is if my area is quadrupled, that is my a squared. A squared is quadrupled. What happens to the perimeter? Well, if my area is quadrupled, my perimeter is going to change by a factor of A. A would have to be 2. And 28 to 56, it's times by 2. So I can say my perimeter multiplies by 2. Okay? Let's check that out with a circle. In question 3, it says a circle has a radius of 6. So I'm going to give myself a visual, radius of 6. The area is doubled. What happens to the radius? So here, my area is doubled. I want to know what happens to the radius. I could go ahead and calculate the area and the new area and try to figure out the radius, but I'm going to take a little bit of a shortcut here. If my area is doubled, that tells me that the a squared factor is 2. What about my radius? Well, my radius is a dimension, and so the dimension is going to change by a. I don't know what that is right now, but I know a squared is 2. The radius is going to change by a. What would that be? Well, to solve this, we would take the square root of both sides, right? And the square root of 2 isn't a very nice number, so you know what? They're just going to leave it as root 2. And they're going to say, your radius is going to multiply by root 2. And that's how they would leave their final answer. Now, if you calculate that out as a decimal, you're going to see that it's about 1.4, and I would take that answer as well. Okay, last one. It says the base and height of a triangle are multiplied by 1/3. What happens to the area? Now, they don't give me any numbers here, any picture, and you could maybe sketch one if you wanted and put some numbers in. But I'm going to say, let's take a little bit of a shortcut. The base and height are multiplied by 1/3. Do you agree the base and height are dimensions? So what that tells me is if the base and height are multiplied by 1/3, A is 1/3. I want to know what happens to the area. Is the area going to multiply by 1/3? No, we know the area multiplies by A squared. What would A squared have to be? Well, if we take 1/3 and we square it, we get 1/3 times 1/3, which is 1/9. So here, my a squared factor is 1/9. And I would say, capital A, my area is going to multiply by 1/9. Without even knowing what those dimensions are, I know that if they're changed by a factor of 1/3, that the area would have to multiply by 1/9. Okay, if you have further questions on this, please stop in to see me, or you can always send me an email.